Consider a very basic application of what we have just learned. You are back to the problem of Captain Kirk that we defined at the beginning of the course, which is that you need to solve one of the three big economic questions by choosing how should Q units be produced. Okay, so you need to achieve this much production. How should it be produced? Given that every firm, every company that gets started, if you wish, every factory has the same technology. So there is a constant technology in society, and the question becomes how many firms should you have? And in this first example, suppose that the technology looks like this. You have one technology that is defined by an average total cost curve that looks like this, that has a minimum that applies there. Now, what would be your goal if you will be Captain Kirk solving this problem? Your goal will be to minimize the total cost of production Q. Now, your choices are going to be how many firms, and the number of firms, and then how much to ask every firm to produce. Now, what's going to be the solution? It's very intuitive. If you look at this average total cost curve, to minimize total cost, ideally you would like to have every unit produced at the minimum possible average total cost curve. So that means that the number of firms that you're going to want to set up is going to be approximately Q divided by QATC mean. It may not be exactly because of an integer problem, but think of this as a good approximation if Q is very large, and then the amount that you're going to want to produce in every of the firms is going to be approximately this point, the one that is close to the minimum. So it's going to be approximately QATC min. This is an interesting insight because it's telling you that the number of firms that you're going to want to set up as Captain Kirk solving this problem is going to depend a lot on the scale of production in society, how much you need to produce, relative to the scale of the technology at which the minimum level of production is accomplished. When this ratio is very high, you want a lot of firms. When this ratio is very low, you want a very low number of firms. I understand, let me emphasize that this is an approximation, and some of you are very careful and may want to play with what exactly is the solution when this is not an integer, but that is not particularly economically interesting, which is why I'm setting the solution like this. Now, one special case that is quite interesting and deserves a special discussion is the case of a cost function that looks like this. So remember, this is the semi-fixed cost, and then these are the variable cost, which is slope mu. That was the case of constant returns to scale with semi-fixed cost that we discussed before. The reason this one is interesting, because if you remember, the average total cost curve, if this is mu, looked like this. It was ever decreasing without ever reaching mu. In this particular cost, the best that you can do is set for any Q n equals 1, and the amount produced by the firm is Q. In other words, when you are in this world in which, because of the semi-fixed cost, average total cost is ever decreasing, you only want to set up one firm. So that's an important case that we're going to come back when we study markets under perfect and imperfect competition.